In this video, I'm going to estimate the volume of this solid right here with the rectangular prisms, and then I'm going to use the double integral method to get the exact answer. And this is the plane z equal to 4 minus x minus y. And then this is the curve y equal to 0.5 x squared on the x, y plane right here. And then this is region R. And then I want to find the volume between region R and the plane z equal to 4 minus x minus y. And this is what the solid looks like. So from here to here is 4, and then from here to here is 2. And so this point right here is the point x is 2, y is 2, and z is 0. And then notice that this line right here, it crosses the y-axis at 4, and then it crosses the x-axis at 4. And therefore the equation for this line will be y equal to 4 minus x. And what I'm going to do now is I'm going to divide region R right here into many rectangles. And so once again, this is 1, 2, 3, 4. And then this is 1, 2. And so right now I have the rectangles from here to here is 0.5. From here to here is 0.5. Meaning the width of each rectangle is 0.5 and the length of each rectangle is 0.5. And so delta x, meaning the width or the length of the rectangle in the along the x-axis right here is 0.5, and then delta y is also 0.5. And so here's the first rectangular prism. And then to calculate the height of this rectangular prism, what I did was I picked a point right in the middle of this rectangle right here. And so from here to here is 0.5, from here to here is 0.5, and therefore the point in the middle will be 0.25 for the x and 0.25 for the y. And then using the function z equal to 4 minus x minus y here to calculate the height of this prism. And then the volume of the prism is just the height times the area of the base rectangle right here. And then here's the second prism. And so I'm going to estimate the solid with 20 rectangular prisms. And now I'm going to calculate the sum of the volumes of the rectangular prisms. So I have 20 rectangular prisms, and the sum of the volumes is 6.25. And so the volume of the solid is approximately 6.25. And then to get a better approximation for the volume of the solid, what we can do is decrease the size of delta x and delta y, meaning make the length of each rectangle and the width of each rectangle here smaller. For example, I'm going to make the length and the width of each rectangle as 0.25 and 0.25 instead of 0.5. And so now we have from here to here is 1, and then here the 4 rectangles, and then the same thing along the y-axis right here. And so the rectangles, they're smaller now, and here's what a typical rectangular prism would look like. And then now we have many rectangles inside of region R, and I'm going to calculate the volume. And there are 78 rectangles inside of region R. So we have 78 rectangular prisms, and the sum of the volumes of the prisms is 6.65625. And then now I'm going to make the delta x and delta y, or the length and the width of each rectangle, even smaller at 0.1, and then calculate the sum of the volumes of the prisms is 6.728 when the length and the width of each rectangle is 0.1. Now I'm going to make it 0.05. And there will be 1,877 rectangles, and the sum of the volumes of the prism is 6.78. And then now I'm going to make it 0.01. And when the length and the width of the rectangle is 0.01, there are approximately 46,758 rectangles inside of region R. And the sum of the volumes of the prisms is 6.79826. And then now I'm going to make it even smaller. The length and the width of each rectangle is 0.005. And when the length and the width of each rectangle is 0.005, there are approximately 186,833 rectangles inside of region R. And the sum of the volumes of the prism is 6.79955. And so here's a summary of what I just did. When the length and the width of each rectangle inside of region R is 0.5, then the sum of the volumes is approximately 6.25. And when the length and the width of each rectangle inside of region R is 0.25, then the sum of the volumes of the prisms is 6.65. And when length and width of each rectangle is 0.1, then the sum of the volumes of the prism is 6.728. And when length and width of each rectangle is 0.05, then the sum of the volumes of the prism is 6.78. And when the length and the width of each rectangle is 0.01, then the sum of the volumes of the prisms is 6.79. And then I just ran with the length and width of each rectangle of 0.005. Then there are 186,833 rectangles inside region R. And the sum of the volumes of the prism is 6.79955. And then I also ran the program with length and width of each rectangle is 0.001. Then there are 4,666,708 rectangles inside of region R. And this part, it does take about 4 minutes to run. And the sum of the volumes of the prisms, rectangular prism, is 6.7999. And then we can see here that as the number of rectangles increases, it looks like the volume of the prism is approaching 6.8. And now let's go find the exact answer and see if we get 6.8. And so to get the exact answer, then we have to divide region R here into an infinite number of rectangles, meaning allow n to run to infinity. And then we define this limit quantity here as the double integral. And the double integral, then we can use either the dy dx method or the dx dy method. So in this case, I chose to use the dy dx method. And so since we're doing dy dx, and region R is bounded by the graphs of x equal to 0, y equal to 0.5 x squared. And then this line right here, the x-intercept is 4, the y-intercept is 4. So the slope of this line will be negative 1. And then the y-intercept is 4. And therefore the equation is y equal to 4 minus x. And we're doing dy dx, and so the bounds for x will be constant. So it'll be from 0 to 2. And then the bounds for the variable y will be, it's bounded by the line y equal to 4 minus x, and then below is bounded by the curve y equal to 0.5 x squared. And so the double integral is set up like this. This is the height. This is the surface function right here for z equal to 4 minus x minus y. And then the bounds for the y, and then bounds for the x. And then we can evaluate the inside integral first. Here we're integrating with respect to y. And so 4 minus x will be constant, and so it'll be the constant 4 minus x times y. And then here we have minus y, and so the integral will be minus y squared over 2. And then evaluating from y equal to 0.5 x squared to y equal to 4 minus x. And then we end up with this. And so the volume of the solid is going to be the integral from 0 to 2 of this expression right here. And then when we evaluate this integral, it will end up as 34 over 6, or 6.8. And recall that we saw earlier, as I increased the number of rectangles inside of region R, the sum of the volumes of the prism was approaching 6.8. And so, in summary, the volume of the solid here is, the exact answer is 6.8. And that's the end of the video.